Welcome back to the Java course. In this video, we're going to go over more on data types and variables. We're also going to touch on comments, and I'll show you what those are. And so let's get started. So to start with, the last video, we went over basically the three main types of variables you're going to use in the form of data types you're going to use. Okay. And the data types we went over are string, integer, and double. Okay, there's actually 8 primitive types of variables. Okay, and I'm sure you're asking, well, what is a primitive type? Well, primitive type means it's an old type of variable. It's built into the language. It's a core component of the language. Now, like I said, there's actually 8 of them. I'm going to use what's called comments here. And comments, the way you can do comments is you can do a // okay? And then pretty much everything you type in here, the program's just going to ignore it. Anything it sees after the 2 slashes, it's just going to ignore it. You can do that, or you can do a multi-line comment, which is a / and a star, and then if you hit enter, it will do the star and / on the ending. Now everything you write in between these is just going to ignore. Comments are only there for humans. It's for when you write a big program, you comment things out. You tell how it's supposed to work, what the flow is, why you did it this way, whatever it might be. You put comments in there. That way the next programmer that comes behind you to work on it, he doesn't have to guess why you did this or how this is supposed to work. He doesn't have to actually deal with any of that. So to start with, we're just going to comment a couple things out, and then I'm going to go over these primitive data types. Okay, so the primitive data types as of right now are byte, okay, and then we're going to do short, and then int, we're going to do long, we're going to do float. Sorry about that. Float and double. Okay, so these are the primary data types that we have in here. Okay, so I'm sure you're asking, well, what is the difference between these? Like, why would you use one over the other? Well, this is all about memory space. So this is all about making your program as efficient as possible. Now, back in the day, when computers were really limited on memory, when you had a 128K Macintosh, well, the 128K was 128 kilobytes of memory or of space in the computer to actually work with. Well, nowadays, our computers have gigabytes of memory in them. It doesn't care that much anymore. So these aren't they're not as widely used anymore because programmers don't have to deal with the constraints of not having enough memory space anymore. But to start with, byte is exactly that. It's the size of memory. It's 1 byte in memory. And what that equates to is an integer value that you can go basically 100 or negative 128 to 127 in a positive value. That's as many objects or as much as information as this data type can hold. That's it. It's just 1 byte of memory. It's just not very big. Short is actually 2 bytes, so it's actually double what the what the byte is, which gives you a range of 32,768 in the negative direction, and that gives you a positive value of 32,767. Okay? And I know people are asking right now of why is it that it wouldn't be 128 and 128? Well, the reason being is because in programming, 0 is worth something. 0 is an object. 0 takes up memory space. It might be nothing in most people's idea of what a 0 is, but in programming, it does mean something. It's actually a value that's in memory. So that's why you're missing basically 1 in one direction, right? The integer value, this is a 4-byte size, memory size. So you can see that, 4 bytes, that doesn't sound like a whole lot, but actually that's it's 2,147,483,648 in the negative direction, and then it's a positive 2,147,483,647 in the positive way. Now, long, that's an 8-byte memory size, and I'm not even going to try going into what that is. But needless to say, it's a big number in the negative value and in the positive value. It's a very big number. And one of the things that we've just gone through is all of those are whole numbers, okay? Whole numbers. So they don't have decimal points. They're not fractional. They're not fractions of a number. They're whole numbers. Float, on the other hand, this is a whole number. I mean, this is not a whole number. This is a decimal or a fraction of a number. Okay? Now, float is a 4-bit or 4-byte size, memory space. Double, which is also a fractional number, is an 8-bit. 8-byte. Not bit, byte. These are really big numbers also. And like I said, I'm not even going to try getting into this. And you also got to remember that these all have accuracies past the decimal point. Now, the floating point, or a float, that has an accuracy of 7 digits of accuracy behind the decimal point, or to the 7th place value. The double has an accuracy of 15 digits behind the decimal point, or the 15th place value. Like I said, I'm not even going to try writing out all these because they are too big to write out. But that's where a lot of this stuff comes from. And that's why we have these different data types. Now, the big problem with them is, like I said, in computers nowadays, there's not a whole lot of reason to actually use these. Because as it stands right now, they don't really make a whole lot of difference, one way or the other, because most computers can run very large programs with ease because of all the memory and stuff. And that's why I said in the last video that the string, the int, and the double, these are the ones you're going to see the most. And these are the ones that you're going to use the most, because int and double, that gives you the perfect size for using floating point values or decimal places. And then the int gives you a perfect size number to go as big as you pretty much need to go. I mean, it's a huge number also. Now, there is another primitive data type, and we haven't talked about, and that's the Boolean. Now, what is the Boolean? Well, a Boolean value is just as in mathematics, it's a true or false value. It's an 0 or a 1. It's a yes or a no. That's what it is. So you've got true or false. That's what it equates to. So when you use the Boolean value, that's what you're looking for. You're looking to use it to get a true or false statement back. And then the last one we're going to go over, the last primitive type we're going to go over is char. Okay? Char stands for character. So when you assign this, you can assign it a single character. And of course, when you assign a character in Java, we're going to put in quotes. So if we wanted to assign an A to a char, that would be the value it would have. So these are the 8 primary or primitive type variables that you have in Java. And actually, you have these in most C-based programming languages. Now, I know what you're probably thinking is, well, what about the string? We use string. You said that was a data type. Well, string is a data type, but string is a different type of data type. The string value is not a primitive data type, okay? In the sense that it's not something that's built into the C language. It wasn't a holdover from anything like that. The C language didn't actually have a string data type in it. This is something that was added, and this is why if you look at all of these, when you put them in, they're all lowercase, okay? So int, double, if we do a char, that's going to be lowercase. If we do something along those lines, let's just assign a value to that. And we'll just call that my char. So as you can see, oh, sorry about that. We use single quotes, not double quotes. I had that wrong on there. So as you can see, all these are lowercase, but the string isn't. Why is that? Well, that's because the string is a special type of data type. It's actually a object, or the string object, that we use in Java. It works just like println does, or something along those lines, or the out object. Now we're going to go more into depth into that, and it will make way more sense, but as of right now, all you need to know is that's why string is not a primitive data type, because it's not actually a data type that was built into the C language. This video has drug on a little bit now, so I'm going to actually end the video here, and we're going to go over and pick up where we left off in the next video. To study some of this, I want you guys to actually go out to Google, and I want you to type in each one of these data types and just read up on what Java or the C language has for these data types and what they actually do and why they would be relevant to certain programs and not relevant to others. Okay, well, I hope you enjoyed that video, and I'll see you in the next one.